Students, as we have discussed earlier, the volume of the tetrahedron formed by the three vectors A bar, B bar, C bar is given by V is equal to plus or minus 1 by 6 into box of A bar, B bar, C bar. So, prior to that, in place of A bar, if I take AB bar, this is the what tetrahedron. This is A, this is a B, it's a D, it's a C, right? So therefore, now if I take the what sides as AB bar, AC bar, AD bar, instead of this I can also write 1 by 6 into box of AB bar, AC bar, AD bar. Followed? 1 by 6 into box of AB bar, AC bar, AD bar. Where plus indicates right-handed system, minus indicates they are in what? Left-handed system. Now in place of AB bar, if it is A bar, B bar, it is AC bar, B bar, AD bar, C bar, we can also write 1 by 6 into box of A bar, B bar, C bar. Instead of vectors, if I give the position vectors of A, capital A, comma, B, comma, C, comma, D, I have told already the volume of a tetrahedron is given by 1 by 6 into AB bar, B1 minus A1, B2 minus A2, B3 minus A3. This is the first row. Second row, AC bar, OC minus OS, C1 minus A1, C2 minus A2, C3 minus A3, AD bar, OD minus OA, D1 minus A1, D2 minus A2, D3 minus A3. This is the volume of the tetrahedron found with the 4 points having the what position vectors A1, A2, A3, B1, B2, B3, C1, C2, C3, D1, D2, D3. Let us recall the what concepts of volume of a tetrahedron for an example as a decide. I take let A bar is equal to 1, 2, minus 1 is a 1 vector. B bar is equal to 1, 1, 1. C bar is equal to 1, minus 1, 1. So, be the edges of tetrahedron. In a short form, tetrahedron, edges of tetrahedron having its volume, 2 by 3 cc units, cubic centimeters. Then you take this as a lambda. Okay, then lambda is equal to dash. Look, when A bar, B bar, C bar represents the what? Edges of a what? Tetrahedron, and they represent a tetrahedron of volume 2 by 3 cubic centimeters. Then we are supposed to find out lambda. We know that the volume of a tetrahedron is equal to 1 by 6 into box of A bar, B bar, C bar. Followed? So therefore, I can write 2 by 3 is equal to 1 by 6 into det. Now, when you are writing in the form of x, y, z coordinates, certainly those vectors can be expressed as a base vectors I, j, k as I plus 2j minus k, I plus j plus k. This is what? I minus j plus lambda k. Followed? So therefore, I can write A bar 1, 2, minus 1. This is 1, 1. That is 1. This is what? 1 minus 1 lambda. 1 minus 1 lambda. Now you expand this determinant. This is 2 by 3. You cancel this. This becomes 4. Now 4 is equal to, that is AD minus BC, 1 into, leave this row, this column, lambda plus 1 minus 2 into 1 into lambda minus 1. Therefore lambda minus 1. Minus 1. This is minus 1 into, that is minus 1 minus 1. Okay, this 4 is equal to lambda plus 1, 2 lambda plus 2 plus 2. Okay, now this is nothing but 2 plus 2, 4. This also 4. This and this goes. So therefore, now 1 minus lambda is equal to 0. Therefore, lambda is equal to 1. We got it. This is how you can find out the unknown lambda with the help of what? The volume of a tetrahedron formed by A bar, B bar, C bar. Right. Yes. So I'll give another example for volume of a tetrahedron. What is that? Is in a tetrahedron, this is O, A, this is what? C. Okay. Now, the problem is in a tetrahedron OABC, let Z1, Z2, Z3 be the centroids of the triangle OAB, next OBC, next triangle OAC or OCA, respectively. Let V be the volume of tetrahedron formed by the edges OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar. Right? OC bar is equal to C bar. Then volume of tetrahedron formed by the edges OZ1, OZ2, OZ3 is dash. This is one of the best example. Now I select first. The proof of this one is very simple. V is equal to 1 by 6 into box of A bar, B bar, C bar. This is the volume of a tetrahedron formed by the edges A bar, B bar, C bar. Now I am supposed to find out OZ1 bar, OZ2 bar, OZ3 bar, where G1, G2, G3 are the what? Centroids. Okay. So therefore, now I can write is first OZ1 bar. OZ1 bar is equal to, in this phase, for a triangle OAB, what is the centroid? Centroid is equal to what? A bar plus B bar plus C bar by 3. But whereas in OAB, A position vector is given, B is given. So therefore, I can write A bar plus B bar by 3. Similarly, OZ2, for OZ2 is for what? OBC. I can write B bar plus C bar by 3. In the same fashion, I can also write OZ bar is equal to C bar plus A bar by 3. Followed? Now let us see. V1 is equal to 1 by 6 into OZ1, OZ2, OZ3. Right? OZ3. Now what I do is V1 is equal to 1 by 6 into, what is OZ1 bar? A bar plus B bar by 3. This is B bar plus C bar by 3. C bar plus A bar by 3. Look, box of ABC is nothing but a determinant. What are the properties which are applicable in the determinant? Each and every properties shall also applicable to what? Box of ABC. If you want to multiply any scalar with a matrix, the scalar multiplication of a matrix is defined only when each and every element of that matrix is multiplied by that corresponding scalar. Whereas in determinant, if one scalar is there, that scalar, if you want to multiply with the determinant, it is not possible to multiply with what? For all the three rows or for all the three columns. That scalar, if one scalar k is there, you can multiply to a particular row or a particular column. If k square is there, you can multiply for either for two rows or what? Two columns. If k cube is there, k for first row, k for second row, k for third row. Or else k for first column, k for second column, k for what? Third column. Like that, k cube can be distributed into what? Three rows or three columns. So therefore, when you are multiplying in the same fashion, this is from first row 1 by 3, from the second row 1 by 3, a third row 1 by 3, a 1 by 3, 1 by 3, 1 by 3, therefore 1 by 3 cube. So therefore, V1 is equal to 6 into 27 into box of A bar, B bars, B bar plus C bar, C bar plus A bar. Followed? Now this is one of the best example. You can take them as a formula while doing the what problems. What is this? Box of A bar plus B bar, B bar plus C bar, C bar plus A bar. Now I can write V1 is equal to 1 by 6 into 27 into det A bar plus B bar. The base vectors are A bar, B bar, not IJK. 1, 1, 0, 0, 1, 1, 1, 0, 1 into box of ABC. If they are in terms of IJK, box of IJK is equal to what? 1. No need to go. That goes without saying. Okay. So therefore, now you expand. If you expand, you are going to V1 is equal to, yes, now 1 by 6 into 27. Now expand, this one is 1 into 1 minus 0 minus 1 into this into this minus 1 plus 0. So therefore, this becomes into box of ABC. So therefore, I can write V1 is equal to, yes, V1 is equal to, yes, 1 by 6 into 27 into 2 into box of ABC. Remember, whenever, wherever, if you come across only this part, box of A bar plus B bar, B bar plus C bar, C bar plus C bar, C bar plus A bar, you are liable to write 2 into box of A bar, B bar, C bar. Followed? So therefore, now this and this goes, V1 is equal to, yes, come on, box of A bar, B bar, C bar by 3 into what? 27. Okay, so therefore, now I can write here box of ABC is equal to what? 6 into, I can write 6 into what? V. So therefore, V1 is equal to 6 into 6V by 3 into what? 27. So now this and this get cancels. Therefore, V1 is equal to 2V by what? 27. This is the relation between what? V1 and V. V1 and V. So therefore, so now we can expand, we can also apply. So therefore, we can explore the concept of volume of the tetrahedron to any extent. Okay. Let us recall the what? The volume of a tetrahedron with another type of what? Information. What is that is? Let A bar, B bar, C bar be the edges of a tetrahedron whose volume is 4 cc, then the value of A bar plus B bar dot of B bar cross C bar, B bar plus C bar dot of C bar cross A bar, C bar plus A bar dot of A bar cross B bar is equal to dash. Is equal to dash. Now, what I do is, now V is equal to 1 by 6 into box of A bar, B bar, C bar. Why? When A bar, B bar, C bar are the edges of a tetrahedron, what's the volume? V is equal to 1 by 6 into box of A, B, C, which implies box of A bar, B bar, C bar is equal to how much is given? 4. Is equal to 4 into 6 is equal to how much? 24. Right, followed? Okay, V is equal to 4 is given, cross multiply, it's a 6. Hereafter, whenever, wherever you come across box of ABC, you are liable to write 24. Now let us find out the value of this. A bar plus B bar dot of B bar cross C bar, B bar plus C bar dot of C bar cross A bar, C bar plus A bar dot of A bar cross B bar, right? Now you take the dot product of A with this one. In a scalar triple, before expansion, one must be aware of what? In a scalar triple product, the vectors can be interchangeable in a cyclic order without the order sign changes. Meanwhile, in a determinant, if the elements of any two rows or a columns are identical, value of the determinant is equal to 0. Henceforth, that same concept can also be extended to what? Scalar triple product. In a scalar triple product or in a box product, if two vectors are identical, the value of a box product is equal to 0. Value of a scalar triple product is equal to 0. Why scalar triple product is nothing but a real number? 0 is also that. So therefore, with this one, A dot of B cross C, B dot of B cross C, two B's are repeating, therefore it's a 0. No need to write. Next, B dot of C cross A, box of BCA, C dot of C cross A, C is repeated twice, it's a 0. Next, C dot of A cross B, C, A, B. Next, A dot of A cross B, A is repeated twice, therefore 0. I can write this is nothing but box of ABC. Yes, this is in cyclic order, box of ABC. This also in cyclic order, box of ABC. Nevertheless, 3 into box of A bar, B bar, C bar. Box of ABC is equal to how much? 24. Come on, apply. That gives the answer. This is all about the application of what? The volume of a tetrahedron. Followed? Right. Now, especially for advanced, mains and advanced, look here. One passage which comprises the entire information regarding the parallelepiped and tetrahedron. Earlier, I discussed about parallelepiped. We found out under the different constraints, we found out the volume of a parallelepiped. And under the different conditions, parameters, we found out the what? Volume of a tetrahedron. Let us see what is that is. I go to this one is, it's a comprehension. So it is not a problem oriented, it's a concept oriented, right? Passage. Let A bar, B bar, C bar be 3 vectors and modulus of A, modulus of B, modulus of C is equal to 2, and angle between A bar comma B bar is equal to angle between B bar comma C bar is equal to angle between C bar comma A bar is equal to pi by 3. Now I want to find out, the first question is volume of a parallelepiped. Okay, volume of a parallel. The very first question is the volume of parallelepiped with edges A bar, B bar, C bar with edges is given by what? V is equal to box of A bar, B bar, C bar. But before that, we know it already, box of ABC, look here, box of ABC, vectors are not given. What is given? If the vectors are given, say for example, A bar is equal to some vector, B bar is equal to some vector, C bar is equal to some vector, you can write directly determinant. Where is the vector? You cannot write determinant. Then you have to go in another way. What is the way out? As we have discussed earlier, box of ABC whole square, we have expanded product of two determinants we expanded. Box of ABC whole square is equal to box of ABC into box of ABC. So therefore, whole square is equal to, we know it. Yes, what is that? This is nothing but A dot A. Next, B dot B, that is B dot A dot C, B dot A, B dot B, B dot C, B dot A same as A dot B, C dot A, C dot B, C dot C. Without this concept, it's difficult to find out the what? Volume. So therefore, now he has given, now what is, let us find out what is A dot A. A dot A is equal to what? Mod A whole square is equal to what? A square is equal to 4. Next, what is common? This is nothing but B dot B is nothing but C dot C. Over. 3 data over. Meanwhile, what is A dot B? A dot B is equal to mod B into cos pi by 3, right? So therefore, 2, it's a 2 is equal to 1 by 2, get cancels, therefore 2. Therefore, B dot C is also 2, C dot A is also 2. Followed? Now I find out box of A bar, B bar, C bar whole square is equal to, yes, come on, 4, 2, 2, 2, 4, 2, 2, 2, 4. Followed? Followed? Now coming, this one is, this is nothing but 4 into 16 minus 4 minus 2 into 8 minus 4. This is 2 into, yes, come on, 4 minus 8. Now this is nothing but 12. 12 into 4. 12 into 4, 48 minus 4 minus 8 minus 8. 8 minus 4, 4. 4 into 8. Next, this is minus 8. So therefore 16. Now this is nothing but 16. Now this is nothing but 32, right? So box of ABC whole square is equal to what? 32. So therefore I can write box of ABC is equal to what? Root 32. This is nothing, okay, the root 32. So therefore the volume of parallelepiped is equal to root 32. Followed? This is the first question in the comprehension. Okay, right. Now I go to the second question. The volume of the parallelepiped is nothing but root 32. Next, question number 2. The volume of a tetrahedron with the edges A bar, B bar, C bar is 1 by 6 into box of A bar, B bar, C bar is nothing but root 32 by 6, right? That's the second question. Once you find out box of ABC, it's enough. The third question is Q3. The volume of a prism with the edges A bar, B bar is nothing but 1 by 2 into box of A bar, B bar, C bar is nothing but root 32 by 2. This is volume of a prism. Remember, we discussed about parallelepiped, tetrahedron. The new data has come. Volume of a prism is half into box of A bar, B bar, C bar. Next, third question is over. Next, coming to fourth question. I want, if V is the volume of a parallelepiped with the edges, then edges A bar, B bar, C bar, then its height is dash. then its height is dash. Next, okay, then its height is dash. Now to find this one is, what I do is, I explained parallelepiped. What is in the parallelepiped? Look here, this is this, right? Okay, now this is nothing but, yes, come on, OB bar or else OA bar, A bar, this is what? B bar, this is what? C bar, right? This is nothing but what? N cap, this is nothing but A bar cross B bar. I want to find out what? Come on, this is the height. Right? This is a height. Height is the perpendicular distance from the point C to the face. Face means what? Parallelogram. In a parallelepiped, every face is a parallelogram. So therefore, is nothing but, what is volume of a parallelepiped? The volume of a parallelepiped is equal to the area of a parallelogram. Parallelogram with adjacent sides A bar comma B bar into CH. This is a height. So volume V is equal to how much? Root 32 is equal to area of a parallelogram modulus of A bar cross B bar, right? Into what? Height. This is a H. So therefore, what is modulus of A cross B? Modulus of A cross B is equal to 32 is equal to mod A mod B into sine theta sine pi by 3. Why? Angle between A bar and B bar is pi by 3. B bar comma C bar is pi by 3. C bar comma A bar is pi by 3 into modulus of N cap into H. Now this is nothing but 2 root 3 by 2. Therefore, 32 is equal to 2 into root 3 by 2. 1, 2 get cancels into what? H. Now you cross multiply. This is nothing but root 32 by 2 root 3 is nothing but a height of in a parallelepiped. Got it? This is how you can find out. In the same way, I'll go for another question. Remember, if V is the volume of a parallelepiped with edges A bar, B bar, C bar, then its height is dash. So therefore, now the volume of a parallelepiped is nothing but the area of this face into height. Height is nothing but the perpendicular distance from the point C to the what face. Therefore, I can write area of a parallelogram, face is a parallelogram, a modulus of A bar cross B bar. It's a vector product. It comprises many more concepts. Vector product, you have to go for volume of a parallelepiped, you have to go for perpendicular distance also. Got it? It's much more involved. So therefore, what I do is, now what is, come on, modulus of A cross B? First of all, you think about A cross B, mod A, mod B, sine pi by 3 into N cap. Why? Angle between A bar and B bar is pi by 3. Similarly, B bar comma C bar, B bar comma C bar is also pi by 3. C bar comma A bar is also pi by 3. So therefore, I take 2 root 3 by 2. This is modulus of N cap is 1 into height. Therefore, height is equal to root 32 by 2 root 3 is the height. The fifth question is, if V is the volume, of a tetrahedron with edges A bar comma B bar comma C bar, A bar comma B bar comma C bar, then height is dash. Yes, this is also very logical question. Now if I go for a what? Tetrahedron, this is A, B, C, it's a D. Right? Now this is nothing but height, as we have discussed earlier. This is nothing but a height. This is h is nothing but a height or a perpendicular distance from the vertex D to the face triangle ABC. In a tetrahedron, every faces are what? Triangles. Followed? So therefore, now that height you are supposed to find out. Now if I take this as A bar, if I take this as B bar, if I take this as C bar, let it be. It makes no difference. No sir, for AC bar you take C bar, take it. What is that? Now I can write the solution part is the volume of tetrahedron V is equal to 1 by 6 into, or else 1 by 3 into, I can write 1 by 3 into area of triangle OBC into height. I can write 1 by 3 into 1 by 2 into, it's a A bar cross B bar. Why? Area of a triangle with the what? Sides A bar and B bar is what? A cross B. Into height. Followed? So therefore, I can write V is equal to root 32 into 6, cross multiply, 3 into 2, 6, is equal to, yes, modulus of A cross B, mod A, mod B, sin pi by 3 as we have calculated earlier into H. Now 6 root 32 is equal to 2 into root 3 by 2. So therefore 1, 2 get cancels. Here also get cancels. 3 remains. Into what? Height. So therefore now I can write 3 root 32 by what? Root 3 is equal to H. This is nothing but height. So this is how you can analyze the concepts of formation of a tetrahedron, formation of a what? Parallelepiped, for suitable examples. So one who knows the what? Entire proof of that theorem, then only he can do it this problem. Otherwise, little difficult in tackling them. So therefore, try to analyze the what? Concept carefully. Let us discuss very few properties in tetrahedron. In a tetrahedron, if two pairs of opposite edges are perpendicular, then the third pair is also perpendicular. Nevertheless, angle between them is what? 90 degrees. Angle between them is 90 degrees. So therefore, what I do is, in a tetrahedron, if two pairs of opposite edges are perpendicular, then the third pair is also perpendicular. Let us see what is this tetrahedron O A B C, right? If it is extended, it will be perpendicular. Now, in a tetrahedron, OABC, let OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar be the edges or be the position vectors of A, B, C, right? Now, I can write this one as OA bar dot BC bar is equal to 0. Two pairs of opposite edges is given. Next, let us consider AC bar dot OB bar is equal to 0. Then we have to prove that third pair is also perpendicular. Third pair is also perpendicular. So therefore, what I do is, now OA bar is A bar. This is BC. I can write C minus C bar minus A bar is equal to 0. Now you take the dot product A dot B, A dot C minus A dot B is equal to 0, which implies A dot C is equal to A dot B. Next, this is C bar minus A bar dot B bar is equal to 0. Now take the dot product B dot C minus A dot B is equal to 0. B bar dot C bar is equal to what? A bar dot B bar. You call this as a 1, you call this as 2 from 1, 2, right? From 1 and 2, A dot B is equal to A dot C is equal to B dot C, right? A dot B is equal to B dot C, A dot B is equal to A dot C. Don't cancel. Therefore, it becomes A dot C minus B dot C is equal to 0. A bar minus B bar dot C bar is equal to 0, which implies AB bar dot OC bar is equal to 0. Means, what we have proved, AB bar is perpendicular to OC bar. AB bar is perpendicular to OC bar. So hence, we can say in a tetrahedron, if two pairs of opposite edges are perpendicular, nevertheless, third pair of opposite edges are also perpendicular. Yes, with this concept, we are proving the another property. This is the data is most important. What we have proved, A dot C is equal to A dot B, B dot C is equal to A dot B, means A dot B is equal to B dot C is equal to C dot A. Be careful. We are using that condition. The definition of regular tetrahedron. Now, in regular tetrahedron, it has 6 edges. A, B, C, D. AB is a one edge, AD is another edge, AC is another edge, and BC is another edge, CD is another edge, BD is another edge. Totally 6 edges are there. Length of all the edges, length of all the sides are equal. And it has 4 faces. Each face is a triangle, that too equilateral triangle. Be careful. Equilateral triangle. It has 4 faces. Each face is a what? Triangle. So it's not ordinary triangle, it's a what? Equilateral triangle. That is called regular tetrahedron. In a regular tetrahedron, length of all the sides are equal. And it has what? Come on, 6 sides, 6 edges, all equal. Meanwhile, it has 4 faces. All the four faces are what? Equilateral triangles. That is called a regular tetrahedron. Students, in regular tetrahedron, we shall discuss about one of the important property. The length of the altitude from any vertex to its opposite face. The length of the altitude from any one vertex to its what? Opposite face. This is the opposite face. Face is a triangle. Triangle means what? Equilateral triangle. Now, when this is opposite face, total angle is 60. This is what? 30. In a regular tetrahedron, length of all the sides are equal. What is its length? We don't want also. I have taken, let it be lambda. With this, I am supposed to find out OH. OH is the what? Length of the altitude from the what? Any vertex to its what? Opposite face. Now, in regular tetrahedron, OA, OC, AB, next BC is equal to lambda. Length of all the sides are equal. Draw a line from O to this face called as H. It's a perpendicular. From this you construct a small triangle. This H, this is HM is perpendicular and is also midpoint of this. When total length is lambda, this length is what? Lambda by 2. This length is lambda by 2. Total angle is 60. The triangle is what? Equilateral triangle. The angle in a what? Triangle is what? 60, 60, 60. So therefore, half angle is what? 30. So therefore, now what I wrote is, from triangle AHM, I will write cos 30. What is cos 30? Cos 30 is nothing but AM by AH. AM by AH. But AH, look here, AH, I am supposed to find out, AH is nothing but AM by cos 30. What is AM? AM is nothing but what? Lambda by 2. I told M is a midpoint. Therefore, lambda by 2. Cos 30 is what? Root 3 by 2. 2 and 2 get cancels. Lambda by root 3. What we proved? AH is equal to lambda by what? Root 3. AH is equal to lambda by root 3. Followed? Now I want to find out OH. Now from this triangle OH, now look here, OH is nothing but OA square minus AH square. Followed? Now this is nothing but what is OA square? Lambda square minus lambda square by 3. Therefore, lambda is taken outside, that is 1 minus 1 by 3. Therefore, OH is equal to lambda into 3 minus 1 by 3. Therefore, lambda into square root of 2 by 3. This is nothing but the length of the altitude, from any vertex to its what? Opposite face. Opposite face. Students, the another property in that tetrahedron is the sum of the squares of two opposite edges. Sum of the squares of two opposite edges is the same for each pair of opposite edges. Is same for what? each pair of opposite edges. Now, what I do is, I have taken OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar. O is the origin. Right? Now let us consider OA bar square. This is one edge. Opposite edge is BC bar square. What is A bar square? This is A bar square. This is nothing but C bar minus B bar whole square. Now expand it. A bar square, C bar square, B bar square minus 2B dot C. You call this as a 1. Similarly, OB bar square extended length plus AC bar square is equal to B bar square, C bar minus A bar whole square, B bar square, C bar square, A bar square minus 2A dot C, you call it as 2. Next, if you go for what? OB bar, OC bar square plus AB bar square. This is OC is per what common opposite edge is what? AB. Now I can write C bar square, B bar minus A bar whole square, A bar square, B bar square, C bar square minus 2A dot B. Just now we had about discussion in tetrahedron. So therefore we know that A dot B is equal to B dot C is equal to C dot A. Just now I told. By using this, now here also A dot B, here also A dot B, here also A dot B, correct or not? So therefore I can write OA bar square, BC bar square, OB bar square, AC bar square, OC bar square, AB bar square is equal to A bar square, B bar square, C bar square minus 2 into A dot B or 2 into B dot C or 2 into C dot A. All are same. So therefore we have proved the sum of the squares of the what or two opposite edges is the same for each pair of opposite edges. Sum of the squares of the two opposite sides is the same for what? Each pair of opposite edges. So therefore that is OA square plus BC square plus OB square plus AC square, OC square plus AB square is equal to, we have proved, A square plus B square plus C square minus 2 into A dot B or 2 into B dot C, 2 into C dot A. Thank you.